Learning objective and key concepts for this module for common network topologies and infrastructures. The learning objective is describe common network topologies and infrastructures and incorporate them into a secure network design. Key concepts: network devices, physical and logical topologies, IPv4 and IPv6 addressing, network infrastructures and related security concerns. Common network topologies and infrastructures. A computer network. It allows organizations to share information and resources to enhance employee productivity, streamlines inventory management of data files and resources, enhances communication and collaboration, provides centralized storage, enables authorized users to access information quickly and efficiently, is composed of different devices connected with common addressing schemes, uses IPv4 and IPv6 as primary methods of addressing. What is a network topology? Network topology references the order and arrangement of the elements of a communications network. It also is how computers and peripherals connect, the communication methods required hardware, whether redundancy exists. Network diagrams and maps also are part of the topology. They aid in understanding the connections and communication pathways that exist and are essential for troubleshooting. Types of network devices you might find in a network. A hub, punch-down block, a smart hub, a repeater, switch, router, bridge, transparent bridge, source routing bridge, B router, and gateway. A hub on a simple local area network. The hub would connect file server, print server that controls the printers, desktops, and laptops. A switch. There's an example of what a 1RU 48 port switch would look like. And this is a layer 2 device. An example of switch deployment. Here we have an example of multiple switches in a network, and we have layer 2 switches that are connecting local devices, and then a layer 3 switch. Now, a layer 3 switch is not a router. It can participate in routing, but it's not a router. And more than likely, we're in this scenario here, we're deploying VLANs to segment different networks in this example. This is an example of an IEEE 802.3 Ethernet Type 2 frame. And notice in the frame, the first part of the frame is the destination MAC address, the source MAC address, and the ether type, and that's 14 bytes that make up the MAC header. Then you have the payload and the footer, and the payload is where the data is, and the footer is where the CRC or error checking checksum is. This is an example of a home wireless router. A routed network deployment. As you can see here, the layer 3 devices that segment the network into collision domains are the interior router, the border router, and the firewall. And that's the path to get to the internet, or from the internet to get to the interior. Here's an example of a MAC layer bridge deployment, and as you can see, the bridge is basically another type of switch, and we're segmenting the network into two halves. We have the left side where we have the router, and that's a collision domain, and then over here on the right hand side, all of that is a broadcast domain. All of these devices on the right side can hear and listen to each other, but they can't hear the left side because that's a broadcast domain. A gateway connecting two networks. A gateway is just like the front door of a room or a house. The gateway is how to get in and out of a network. As you can see, the left-hand side can talk to anybody. That would be a broadcast domain. The gateway would be the router, and that'd be the .1 or the way out of that network on the left-hand side to get to the network on the right-hand side in the computers on the right-hand side can talk to everybody, but they cannot talk to the computers on the left-hand side. They need that gateway to be able to communicate across to each other. What's the difference between a logical and a physical topology? Physical topology is the way computer networks are physically connected, whether wired or wireless. All computer networks have physical and logical topologies. Wired topology, the physical wire between devices that allows communication between devices. A route is the pathway that communication packets travel within the wired connections of a network. Logical topology is governed more by policy and access than by physical connectivity. Focuses on how the connected computers access and share data and resources. Types of physical topology. Bus topology. A linear network, computers are connected in a line. Equipment requires terminators at the end of physical cables. Ring topology uses a closed cabling scheme. Each computer or device is connected to two devices, one on each side. Requires a special packet called a token. In unidirectional rings, the token moves in only one direction. In bidirectional ring, there are two connections to each device. This is an older type of technology. It is called token ring. It is not used today. A star topology provides a layer of performance protection not present in bus or ring topologies. Independent cables are attached to each device. The entire network will not be brought down if one segment is disrupted. This is pretty much what we use today. Mesh topology, most redundant of wired topologies, allow for full and partial connections, provides isolation for devices and redundancy if a segment of a network no longer functions, thereby allowing communication. And an example of that today would be a VXLAN type connection or network. Wireless topology, it requires minimum wiring. Devices connect using the air as a medium of exchanging communication packets. At least one wireless router is present. Logical topology focuses on connections and permissions. It's important for separation of duties and access. Limits access to data and resources to individuals and devices that require access. Segmentation protects employees from accidental accessing, altering, or deleting information. Aids in legal compliance efforts by supporting least privilege and separation of duties. Aids in hiding assets. Here's a representation of logical topology. We're not looking at each individual connection, switches, and routers, but logically following a packet from the internal LAN to the internet, or from the DMZ to the internet, or from the DMZ into the LAN, or the DMZ to the server LAN, or the server LAN to the internet. Creating logical topologies. There's two main ways to create logical networks. One, by subnetting, which was created by the OSI layer 3, or the network layer. Virtual local area networks, which are VLANs, created by the OSI layer 2, or the data link layer. VLANs are logical partitions on a network that define groups of hosts. We see in this figure that there's a building that has 3 floors. The first floor that has a switch that has 3 VLANs configured on it, just like the other 2 floors above it. We notice the first computer that's attached to the switch is in the engineering VLAN. And the second PC in that same first floor is connected to the marketing VLAN, and the third PC is connected to the accounting VLAN. Even though they're connected to the same physical switch, they cannot talk to each other because the VLANs electrically isolate them from each other. But the first floor can talk to the second and the third floor PCs in the engineering VLAN. Same goes for the marketing and accounting. They still can't talk to each other. The only way they can talk to each other is they have to go to the router, and the router points them to the network they're trying to talk to, and they'll come back to the switch and go to the appropriate VLAN. Differences between IPv4 and IPv6. IPv4 is predominant protocol on the internet for about 3 decades. It's a connectionless protocol, operates at the network layer of the OSI model. It's the foundation of the TCP/IP suite. IPv6 is the successor to IPv4. It uses 128-bit addressing, increased address space. It has more efficient routing, reduces management requirements, has better quality of service, better security. It's dual stack, tunneling, and translation. Comparing a typical IPv4 address to an IPv6 address, we see in this example IPv4 is dotted decimal notation 192.168.12.153. Its binary representation is below, and the dotted decimal notation is 256 bits per octet, so each one is worth 256 bits. And below, IPv6 is a hexadecimal notation, and it's a 16-bit notation from A to F and from 0 to 9. The binary is represented below. IPsec and IPv6. Internet Protocol Security, IPsec, is a mandatory component of IPv6 used natively to protect the IPv6 data. IPv6 also, IPsec and IPv6 uses an authentication header, an encapsulation security payload, extension header, internet standards that use cryptographic security services to provide confidentiality, data origin authentication, and data integrity. Examples of network infrastructures and related security concerns. So we can put a work group in a container, small office, home office, client server, LAN versus WAN, thin client to terminal services, remote control, remote access and VPN, and boundary networks. Here's a typical work group network. Everybody in this network and all these workstations share the same workgroup name, so they can talk to each other. A small office, home office network is a smaller networks found in small businesses, may be deployed in a home, garage, portable building, or lease space, may be workgroup or client server, may more secure than a typical workgroup, and more likely to employ security tools such as antivirus software, firewalls, and auditing. Client-server networks, a form of network where you designate some computers and servers and others as clients, are more likely to use hardware or appliance firewalls, may employ single sign-on, and invariably more secure than a SOHO or workgroup network. This is a typical example of a client-server network. The clients are independent to themselves for local applications, but there could be applications that are hosted in the data center or somewhere else to get services, such as this print server, web server, or a backup server, and they're all connected via the layer 2 switches. They have a firewall appliance that protects this network from the internet. Local area network versus wide area network. LAN is located within a single geographical area. Segments, links are owned and controlled by one organization. Doesn't contain or use any leased or externally owned connections. The network owner has the responsibility for ensuring security is enforced. Wide area networks, or WANs, not limited by geographical boundary, use leased or external connections and links, often relies on telcos for WAN circuits and links to physical buildings. Data is only secure if encrypted before transmission. The leasing entity selects a secure telco and establishes a SLA for the benefit of the customer. Thin clients and terminal servers. These were early computing models. The computing core or mainframe was controlled through a terminal interface. A video screen and keyboard was the terminal. no local processing storage was on the terminal. All activities occur on the mainframe with results displayed on the terminal screen. PC computing, which is kind of more modern, is workstation computer offers a local processing and storage. PCs become the clients of the client-server model. Modern networking environment, PCs may be used as workstations or clients. PCs can run thin client software which emulates the terminal system of the past, or VMs. Remote control, remote access, and VPN. Remote control is the ability to use a local computer system to remotely take over and control another computer over a network connection, or RDP would be a good protocol, remote desktop. Remote access to network resources using a WAN link to connect to a geographical distant network. That'd be like SD-WAN. VPN, a form of network created over other network connections, connects a remote system and a local area network, and that'd be an IPsec VPN. A typical VPN before connection is established. We have our private network, or our corporate network on the left. We have the internet. We have the remote client, or you're at home and you're trying to connect to your corporate network, and you can't just connect over to the your business or your corporate network without a VPN connection, so there's no way to get there. A typical VPN after connection is established. So the remote client on the right has a VPN software, and it's usually either thick client or thin client, SSL, like a web browser, and you're going to navigate or connect to the corporate network, and it's going to just think like before, think of writing a letter to a friend. You're going to encapsulate data, so you're going to take the transmission on the right, connecting to the corporate network, and we're going to write the letter. We're going to put it in an envelope. That's the encapsulation process. We're going to send that across the internet. It's through the tunnel. It's going to establish a tunnel so that when I connect to my private network, the firewall on the corporate network is going to de-encapsulate that traffic, open the letter, and pass the data through. Now, while that tunnel is established, no one can see or hear the traffic that is going across that tunnel, and that's the encryption process. Boundary networks. Here's three types of boundary networks. A boundary network could be a subnetwork at the edge of a LAN, which isolates certain activities such as programming and research and development from private LANs. Demilitarized zone, or DMZ, used by external users to access resources hosted in a boundary network. Hosts the resource servers for the public internet, meaning I want to put my servers out in the DMZ for anybody on the outside so they don't come back into the local network. They can only access that DMZ. An extranet, a boundary network that hosts the resource servers for a limited and controlled group of external users. Boundary networks and DMZ deployment options. Screen subnet using 3-homed firewall creates a network segment for the private LAN and a network segment for the DMZ or extranet. A 3-home firewall serves as a filtering device as well as a router to control traffic entering those two segments. N-tier deployment creates a series of subnets separated by firewalls. A DMZ or extranet subnet serves as a buffer network between the internet and the private LAN. The N tier is a variable to be replaced with whatever number of tiers are built into the network. A DMZ or extranet deployed as a screen subnet with a 3-home firewall. Here we can see the VPN established between a remote client and a LAN over the internet. A DMZ or extranet deployed in an N-tier configuration. Here we have a firewall at the exterior of the network, then the DMZ, and then another firewall before you get to the private LAN. In summary, we've talked about network devices, physical and logical topologies. the IPv4 and IPv6 protocols, and network infrastructure and related security concerns.